the serotonin connection. New research unveils a possible link between mood and tinnitus for millions of people. Tinnitus, the perception of phantom noises like ringing, buzzing, or hissing, is a relentless and often debilitating condition. While often linked to physical ear damage, recent scientific evidence suggests the noise may actually be a neurological phenomenon originating in the brain. A new study published in the Proceedings of the National Academy of Sciences has identified a specific brain circuit involving serotonin that may play a direct role in triggering tinnitus-like symptoms. The serotonin dilemma. Serotonin is a well-known neurotransmitter responsible for regulating mood, sleep, and anxiety. Because of its role in emotional regulation, it is the primary target for selective serotonin reuptake inhibitors, SSRIs, a common class of antidepressants. This creates a clinical challenge. Many tinnitus sufferers also experience depression and anxiety. If the very drugs used to treat those mental health conditions influence serotonin levels, there is a risk they could inadvertently exacerbate the phantom sounds of tinnitus. For years, scientists suspected a link existed, but the exact biological mechanism remained a mystery. Uncovering the brain circuit to bridge this gap, researchers from institutions in the US and China conducted experiments on mice to map how serotonin affects the auditory system. Their findings pinpointed a specific pathway. The source, the dorsal raphe nucleus, a region in the brainstem that produces serotonin. The destination, the dorsal cochlear nucleus, a critical region for processing sound. By using genetic tools to activate serotonin-releasing neurons in this specific circuit, the researchers observed a startling result. The mice began to behave as if they were experiencing tinnitus. Specifically, the animals lost the ability to perceive silence gaps in auditory tests, a standard scientific indicator used to proxy the experience of phantom sound. When we turned that circuit off, we were able to ameliorate the tinnitus significantly, says neuroscientist Zhengquan Tang of Anhui University. This gives us a much clearer picture of what's going on in the brain. Implications for future treatment. The study's findings do more than just explain why tinnitus happens. They offer a roadmap for more precise medical interventions. Currently, many psychiatric medications affect serotonin throughout the entire brain. However, this research suggests that the tinnitus effect is tied to a specific circuit. This opens the door for a new generation of targeted therapies. Region-specific drugs. Developing medications that increase serotonin in areas responsible for mood regulation without activating the auditory link circuit. Improved patient care. Allowing doctors to better manage the delicate balance between treating depression and preventing the worsening of auditory distress. Conclusion, by identifying the direct neurological pathway between serotonin and the auditory system, this research provides a vital piece of the puzzle in understanding how the brain generates phantom sounds. It paves the way for more sophisticated treatments that can address mental health and tinnitus independently, rather than forcing patients to choose between emotional stability and auditory peace.